Hello. Welcome back to topic 16, 16-3, understanding angles and unit angles, okay? We talked about in the last section, what are the physical components that make up an angle? Now we're gonna start looking at how to measure angles and how to determine measurements of angles, compare it, and all that good stuff. Okay, we have three terms we need to familiarize ourselves with before moving on. The first of which is degree, okay? This, according to the math magicians, is the unit in which we measure angles, okay? It's based upon a circle, so this is the unit we measure with, okay? Same thing with distance, you measure with meters, centimeters, kilometers. We're using degrees for our angles, okay? And this is represented by, okay, here's my variable, I don't know the degrees, but it's just a little degrees right there, okay? A little circle, a little superscript. So, there are 360 degrees in a circle. Again, that is what we're basing everything off of. So, that means 1 degree is 1/360th. And 1/360th written in degrees is 1 degree. Okay, and 1 degree is what's called a unit angle. All right, there are 360 unit angles in a circle. And so when you get whatever an angle is, that's the amount of unit angles it has. And then lastly, your angle measurement is how many unit angles you have. So if you have a 30-degree angle, your angle measurement is 30 degrees or 30 unit angles, okay? We don't often talk in terms of unit angles. We usually talk just in terms of angle measurement because it's very rare that we have 1 degree, okay? But it is a thing. It is important to know that a unit angle is 1/360th, all right? If you thought you were done with division just because we're doing geometry, you are horribly wrong. If you thought you were done with math facts, you are even more wrong, okay? But the nice thing is that this number looks to me like a number that can be found in math facts. I'm gonna let you think of it. And because you are experts at finding equivalent fractions, we can compare to things that are similar and will allow us to figure out unit angles and angle measurements based on that knowledge as well, okay? So, I'm gonna begin by, let's begin simple here, okay? I'm gonna take me circle, all right? I know that to be 360 degrees. Then what I'm gonna do is I'm gonna have 4 sections. Okay, here's the vertex. It's dead center in that circle. And now I have 4 angles, all right? I'm gonna label one angle so we can talk about it because in this example, they're all the same. All 4 are the exact same measurement. So I'm gonna be specific. Okay, that point we'll call A. This point we'll call B. That's the vertex. And this point we'll call C. So angle ABC, what is the angle measurement of angle ABC? So here's where you have to start using those math facts. You have to start using the number sense, using your division, and putting it all together. I know that a total circle is 360 degrees, okay? And I know that I've taken this 360 degrees and I've split it 4 ways evenly. 4 ways evenly. So I can do this, right? And that will work. 4, 9. So 4 goes into 360 degrees 90 times. Or, again, I can use those skills that I've been working on for years now, and I can look at that number, and I can look at that number, and say, I know there's some sort of relationship between those two. What is it? So if you're just looking at 360 divided by 4, you can drop that and get 36 divided by 4. What times 4 equals 36? That's right, 9. And then you put this guy back for 90. Okay, that's how you use your math facts. So, if you take a circle and divide it into 4, you come up with 4 90-degree angles. And what do we know 90-degree angles are? They are right angles. So I've taken something that is the definition of square, literally the definition of square, as you'll find out, and I figured out how it fits within the opposite of a square, a circle. Okay, see how those things go together? So that's how I do when I'm dividing by 4. That's really simple. Let's look at something that's a little more complex. I'm going to draw something here that you may have seen, but in my experience, you're not super familiar with. Okay, I've got my circle. Uh-oh. A clock. Okay. All right. So a clock is a circle. How can we figure out angles on a clock? Well, I know it's 360 degrees, okay? But I don't know how many times yet it's been cut. So if I know a circle, so now it's just time to start, figuring out what I do know before figuring out what I don't know. And that's what we always want to do. Take all the information you do know, okay, kind of weed through and find out the important stuff. But I don't know what the important stuff is yet. So if a circle is 360 degrees, but I know a clock, it goes from 1 to 12. That means it has 12 divisions, 12 even divisions, right? They're not just randomly placed on the clock. Between every number on the clock is evenly split. So now I want to compare 12 and 360. Are you using, is your number sense tingling? That's what I wanted to say. Is your number sense tingling? It should be. You should be looking at this and saying, well, I don't know 360, maybe, but I do know 36 12 divided by 36 is 3, right? 12 plus 12 plus 12. So that means if it's 360, it's 30. So that should be telling me that every division on the clock as set by the numbers is 30 degrees, right? Just by knowing basic math facts, I can already figure out the angles of this circle, this clock. So I could tell you any time and you could tell me that angle. So let's just double check and make sure you're right, okay? Because 12 is the end, I'm going to stop there. I'm going to start there, but I'm not going to give it a number. 1 over, we said one division is 30 degrees. 30, 60, 90. Well, that looks right so far because if you look between 12 and 3 on a clock, it should be a right angle. 120, 150, 180. Between 12 and 6, that looks like a straight angle, which is 180 degrees. 210, 240, 270. I'm 9 divisions in. 9 times 30 is 270 because 9 times 3 is 27. 300, 330, 360. So if you count 30 degrees around that clock, you end up with 360 degrees, which you need to end up with. If you end up with a number other than 360, it's not a circle, or you didn't do your math right. It's one of those two things. Wow. So how does that help me figure out the angle? because all I've done is figure out that each one is 30 degrees and that my right angles, wherever it's square, where those lines would be perpendicular, you have some sort of multiple of 90, okay? 90, 180, 270, 360. So how does it help me figure out the angle? Okay, well now you ask yourself, how many divisions are in between the hands, right? So I go here, 1, 2. So if it's 2 divisions between the hands, it would be 2 times 30 degrees equals 60 degrees. And it shows right there that 2 is on 60. Not bad. Let's draw another one. I'm going to leave the one going up because that's going to make it a little easier for us. Actually, you know what? I'm not. Let's make it a little harder for us. Okay, so there's 1, and there's 2. Uh-oh. So, you know, it says it's 235. Actually, the way I drew it, it's 710. Either way, I want to start counting the amount of divisions along the clock, the numbers, in between those two angles. So I go 1, 2, 3, 4, 5. Okay? 5 times 30, which again we can simplify to 5 times 3 equals 15. So therefore 5 times 30 equals 150. Okay? Does this angle from here to here look larger than 90 degrees? Heck yes it does. Does it look close to a straight angle? Yeah, actually. If this line went all the way between the 2 and the 8, that would be a straight angle. So it should be close to 180. How close? Well, it's only 1 separating the 2. So there should only be 30 degrees difference in between 180, our straight angle, and the angle we have. Is that correct? Yes, that is correct. 180 minus 30 degrees is 150 degrees. So when you're counting along that clock, every number division is 30 degrees. Okay? What about if it is not even on the 5, the minutes? What if it's 2:18 or 2:17? Well, you can figure that out too. And in fact, I'm going to challenge you on that one. This is going to be your challenge one. You're going to have to do some math. Okay, what time did I say? Let's see. We have 2. There we go. So we're going to call the time 2:18. Using the fact that you know in between each number is 30 degrees, and you know that on the clock there are 5 individual minutes in between there, I want you to figure out what the angle of 2:18 is. If you figure out the angle of 2:18 and it's right, and you put it in the math form, I will give you 5 extra dojo points if it is right. If you try it and you're wrong, I'll still give you 2. Okay? All right, so I'm going to erase this, and we're going to look at some other things. Now we're going to take a look at Mr. Fellow's second favorite thing. The first being tacos, the second being pizza. This beautiful pizza I've drawn, okay, this masterpiece, we're going to use again to figure out the angle of each slice, okay, the angle measurement. So I've told you that, you know, my doctor told me to stop eating as much pizza, so instead of eating 8 slices of pizza, I'm now only going to eat 6. So I've cut my pizza into 6 slices. Okay, I don't want to be a liar. I said I would cut down from 8 slices to 6. So I'm going to eat 6 slices, and they're evenly cut. We're going to always assume that the slices are even. I need to figure out the angle measurement of one individual slice. So let's start by putting down what I do know. Okay, I do know that when I eat all 6 slices, I will have eaten 360 degrees of pizza. Kind of sounds impressive, right, when you say it like that? And I know that each individual slice is 1/6. Okay? Therefore, 1 slice is 1/6 of 360 degrees. There it goes again. That number sense is tingling. Okay, that's when you're in danger of missing something in math. So your number sense is tingling. You should know, you should see right away. 6 and 36, something goes together. And we know from our number facts that 6 times 6 equals 36. Okay. Therefore, if we can play our zero trick, we know that 6 times 60 equals 360. Okay, so this is the amount of slices. That's the total degrees. Therefore, this is the angle measurement of 1 slice. Therefore, if I eat 1 slice, 1 slice equals 60 degrees. Okay? But if you're unconvinced, you can always go back and do the math. It will always work because you're not always going to get a nice, even, cute number that goes right into 360 degrees. You might cut it into 7 equal slices, in which case you need to go in here, okay, perform the appropriate math and solve it, all right? But that's what you do. Basically, you figure out how much of a circle the angle is in fractions, whether it's 1/6, 1/12, like with the clock, 1/4, like with our first example, 1/3, 1/2, whatever it is, you need to figure out the fraction of the circle that each angle is, and then you need to divide that 360 degrees by your denominator. All right? Go have a pizza. See ya.